work? Work is done when a force acts through a distance parallel to the direction of the force. We put in bold here the word parallel. The force has to be parallel to the direction that the object is moving. Here I've given you the formula. W equals F times D, where W is work, and it's measured in Newton meters. F is force, measured in newtons. D is distance, measured in meters. And then down here at the bottom, I told you that Newton meters we're going to call a brand new unit that we haven't used yet. That's a joule, capital J. Joule measures energy. Work is an energy, and then all other energies that we do later on, kinetic energy, potential energy, mechanical energy, all of those energies are all measured in joules. Here's an example. A gasoline engine in a lawnmower exerts 1,000 newtons of force on a piston that moves 0.40 meters. What is the work done? Well, we need to always write down our givens. So let's see what's given. First, we have a force that's given. That is 1,000 newtons. There's a distance that's given. That's 0.40 meters. And then it asks, what is the work done? Well, now I need to find a formula. And if we went back, we would see that our formula is W equals F times D. Not too difficult on this one. It's just a plug in and see what happens. So we have 1,000 times 0.40, 400 joules. Of course, if we're going to keep in mind sig figs, we have 4.0 times 10 to the 2 joules. Since work is done when the force acts parallel to the motion, what happens if the force is at some angle other than 0? Here's another problem. How much work is done on a vacuum cleaner pulled 3.0 meters by a force of 50 newtons at an angle of 30 degrees above the horizontal? 50 newtons is not the force horizontally, but instead at a 30-degree angle. How do we find the horizontal component? Well, of course, we're going to use trig again. So if I drew my triangle out, this is the 50 newtons. Since the vacuum cleaner is moving horizontally, I need to find the x component. So I'm going to use, since x is adjacent to that angle, and I have the hypotenuse, I'm going to use cosine. Cosine of 30 degrees equals x divided by 50. You do that in your calculator, you should get 43.3 newtons. So that means of the 50 newtons at that angle, only 43.3 newtons is going horizontally. So, if we use work equals force times distance, the distance is horizontally, that was 3 meters, so we're only going to use the force horizontally, 43.3 newtons. We get 130 joules for work. But they gave us a formula for figuring out the trig, so we don't have to do that extra step. And the formula is W equals FD, like we had already, times the cosine of theta, where theta is that angle. So in the same problem, we can type in our force, 50 newtons, times our distance, 3 meters, times the cosine of our angle, 30 degrees, and we're still going to get 130 joules. So let's go back to the first example. A gasoline engine in a lawnmower exerts 1,000 newtons of force on a piston that moves 0.40 meters. What's the work done? Well, what was the angle? Since the force was the same angle as what the direction of the movement was, the angle is 0. So for those of you that remember from your math class, what is the cosine of 0? Don't say 0. The cosine of 0 is 1. 1 times anything is already going to be the same thing. So if I had work is force times distance times the cosine of 0, and this happens to be 1, whatever my force and my distance are, it's going to be the same number. Power. Power is the rate at which work is done. Power is measured in watts. And we're going to do watts with a capital W. A watt is the same thing as a joule per second. So our formula is going to be P equals W over T. I suggest that you write your fractions always with a horizontal line and not this slanted line. It's kind of hard to do sometimes in PowerPoint. Power is measured in watts, work is measured in joules, time is always in seconds. Some of these problems are going to trick you and they're going to want you to convert minutes or hours or some combination of that into seconds. Always convert it into seconds. It's sometimes useful to remember that work equals force times distance and substitute it into the formula. Power equals force times distance over time. Because remember, force times distance is work. So it's the same formula, just remember that work is force times distance. I'm going to go a step further. If we're talking about stuff in the vertical direction, a lot of times the force might be talking about a weight. So we might say mass times gravity times distance over time. That might help you for the human horsepower lab. Example 1. An 1890 Newton curtain needs to be raised 7.5 meters at a constant velocity in 5.0 seconds. How much power will the motor have to output to raise the curtain? So what's given? Well, I have a force given, 1890 newtons. I have a distance given, 7.5 meters. Constant velocity, so we can just ignore that for right now. That means there's no acceleration. And I have time of 5 seconds. How much power? That's what I want to find. How much power? So, power is work over time. Are we given the work? No, we're not, but we are given force times distance. So I'm going to change the formula to force times distance over time. My force is 1890 newtons. The distance is 7.5 meters. And the time is 5 seconds. My power is 2,800 watts. 2,800 watts. And that is all for work and power.